Okay, let's dig into this. Welcome to this deep dive. Today we're exploring some source material that, well, it builds a really interesting bridge. Connects concepts you might be wrestling with in math class.
Hmm.
Differentiation, integration, connects them to a very specific practical field.
Right. And that field is forest resource technology. The material we looked at, it really zooms in on integration, how it becomes just a fundamental tool there. It's all about taking that abstract math idea, like summing up tiny parts, and using it for something you can actually see and touch, like trees.
Exactly. So the mission for us today is sort of cutting through the abstract theory. We want to show you how these math tools are actually put to work out there. Like, think about something really basic for forestry.
Hmm.
How do you figure out the total timber volume, in a certain patch of forest, a stand? This material shows exactly how integration fits into that picture.
Yeah.
So if you're maybe sweating over integrals right now in college,
Yeah.
this deep dives is definitely for you. It shows this isn't just about textbook problems.
These are tools professionals rely on. And the key thing, I think, isn't just that integration gets used, but really how. The sources explain that figuring out timber volume, well, it's not like measuring a perfect cylinder.
So right, trees aren't perfectly straight.
Exactly. They taper, they get narrower from the bottom to the top, their shape changes. So to get an accurate volume, you need something that handles that changing shape, that changing cross-section, all the way up the tree.
Ah, okay. So you can't just do like height times some average width. It's trickier than that.
Much trickier. And that's precisely where the calculus, the integration, comes in.
Mhm.
Imagine slicing a tree horizontally, like into lots and lots of really thin discs, all the way up.
Okay, like coins stacked up.
Sort of, yeah. Each disc has a super tiny height, and it has a certain area, right, the cross-sectional area at that point. And that area gets smaller as you move up the tree because of the taper.
Okay.
So the volume of just one tiny disc, it's basically its area times its tiny little height.
All right, I think I see where you're going with this. To get the total volume of the whole tree, you'd have to add up the volumes of all those tiny, tiny discs.
You got it. And what is integration, fundamentally? It's the mathematical way to do exactly that kind of continuous summing up. So in forestry, what they do is develop a mathematical function. It's often called a taper equation or maybe a form factor. This function essentially describes the tree's cross-sectional area at any given height you pick.
Huh. So the function tells you the area of one of those theoretical slices anywhere along the tree trunk, let's say at height h.
That's exactly it. And then, to get the total volume, foresters integrate that area function. They integrate it with respect to height, starting from the bottom, height 0, all the way up to the tree's usable or merchantable height. That definite integral, it adds up the volumes of all those infinitely thin slices, and it gives a much, much more accurate volume than just using simple geometry.
Okay, that makes a lot of sense now.
Mm.
Like finding the volume under the curve, but here the curve is actually how the tree's shape, its cross-section, changes as you go up.
Precisely. And what's really fascinating here is seeing how this mathematical idea, developed maybe centuries ago, finds such a critical use. It's directly applied to understanding and managing our actual physical world, forests. And getting that volume right, it's crucial for everything from, say, planning sustainable harvest, managing inventory,
Well,
even estimating how much carbon a forest is storing. It really impacts resource management, economic decisions, too. It's not just theoretical math.
yeah, definitely not just theory. So we've seen how a concept like integration, something you might be learning right now, turns out to be this essential tool. In a field like forest resource technology, it's key for calculating something really concrete, really important, like the total timber volume in a forest stand.
Hmm. Which kind of brings up a bigger point, doesn't it? It makes you wonder, where else are these mathematical tools you're learning right now, quietly working behind the scenes, solving complex problems in fields you might not have even connected to math yet? Think about, I don't know, engineering.
Finance, biology.
Exactly. The applications are just, well, they're potentially vast, something to think about.